So now we are having the 16th question here, and they have given another matrix A, and we have to prove that a cube minus 6a squared plus 7a plus 2i is equal to 0 matrix. This is actually a little bit lengthy process, so I have simplified it as much as possible. So first of all, we have to find out a cubed, right? So a cubed cannot be found out directly. So first of all, we are finding out what is a squared, and a squared is a times a, right? So I am multiplying a matrix twice, and finally we are getting a squared as this matrix. This is our a squared matrix. Then we have to find out a cubed, right? So a cubed is a squared times a, right? There are 3 a's, right? So 2 a's is a squared and 1 a, it's written out. And now we can multiply them. You can multiply in any order, it's okay. You can multiply like a into a square also, that's also fine. And when you do the multiplication, you will arrive at this matrix. This is our a cubed matrix. Now we are finding out what is 6a squared. We already found out a squared, right? So with the a squared matrix, we are multiplying 6, right? So 6 is multiplied with each and every element inside the matrix, and finally you are getting 6a squared as this matrix. Then we have to find out what is 7a. So 7 is multiplied with the whole matrix, and we will get this as the 7a matrix. And finally 2i, right? 2i, it's an identity matrix, right? But instead of 1, we are putting everything as 2. That's the only difference, because we are having 2i. So now let's solve this equation and find out if it is equal to 0 or not. So now according to the equation, I have just replaced a cubed by this matrix, 6a squared as a matrix we found out before, and 7a and 2i. Now we have to just add and subtract. So the corresponding elements of each one, you have to do it together. So 21 minus 30, then plus 7, then plus 2, right? Now 0 0 0 0, so it would be 0. Next 34 minus 48, right? This one minus 48 plus 14 and 0, right? 0 is there. Now second row, 12 minus 12 and 0 and 0, so nothing else. Then next 8 minus 24, then plus 14 and plus 2, right? Now 23 minus 30 and plus 7 and plus 0. Now going to the third row, 34 minus 48 plus 14 and plus 0. Next 0 minus 0 plus 0 and plus 0, so everything would be 0. And finally last one, 55 minus 78 plus 21 and plus 2, right? So actually now if you do the addition and subtraction, everything would become 0 0. It would be 0, this also is 0, and this also would be 0, and this also 0. So all the elements would be 0, so which is equal to the O matrix or 0 matrix. So we have proved out this one is equal to the 0 matrix. So this is the correct answer.